now that we've seen how to do these calculations when we need to know how much we need to have saved up in order to take some set amount out each month, now let's think about it from a different perspective where, okay, this is how much we have. How much can I take out each month, right? So before we knew how much we were going to take out in withdrawals each month, and we want to know how much our principal in the account needs to be in order to be able to do that. Now we're going to be looking at it from the perspective of, well, this is how much I have, right? This is my principal. This is how much I have. I'm retiring today. What can I take out each month in order for it to last 15 years, 20 years, 25 years, right? Whatever that is. Okay, so that's essentially solving for payments instead of solving for what the principal needs to be. And this is going to be similar to what we've had before, where we could use that same formula that we had and just treat the payments like an X, or we could just do some rearranging and solve directly. So that's what I've done here. I've rearranged that payout annuity formula so that we're solving for payments instead of solving for principal. It's the exact same formula, just rearranged with some algebra to get us the thing that we're trying to solve for here. So this is what I'm going to go ahead and demonstrate in the videos. Well, actually, this video. Okay, so let's look at this situation where we've got a conservative investor that's listened their whole life to what people have been telling them, and we consistently see this same advice of needing to have, or planning as a goal to have $1 million saved in our retirement accounts. I've probably already mentioned that this is for in retirement accounts, that's about 3% of people, so it's a great goal, but not one that we should all plan on necessarily getting to. So anyway, the conservative investor might plan on living 25 years after retirement, wants to avoid risky investments, so they're just fine with a 5% return on their investments in order to make sure that they're not, right, like losing money or getting a really bad return, right? It's this nice kind of in between from any kind of risky investment. So if that's how much this person has saved up, how much could they withdraw from their IRA, their individual retirement account, each month? Okay, well, first things first, let's make sure we've got the numbers right. Our principal in this account is going to be $1 million. Our R is our interest rate that we're earning as a decimal, so 5% is 0.05. Our N is 12 because it's going to be monthly withdrawals, and we want this to last 25 years. So again, this is really the key here, is this number that we're about to calculate ensures that we will be able to take that amount out and it will last 25 years. All right, so as I start with that formula for a payout annuity where I'm solving for payments, we just put in 1 million for the principal, 0.05 for our APR, 12 for the number of withdrawals per year, and 25 for the number of years that we're going to be doing this. As usual, I'm keeping every single decimal place my calculator will let me. And as I do this calculation, I come out with $5,845.90 per month. So if this investor takes out that amount, they will run out of money in 25 years. But it will last 25 years, okay? So just be aware of those two sides of this. Yes, it will last the 25 years, but that also brings down the account to $0 after those 25 years. All right, let's look at a similar type of calculation for someone who did not make the best choices in their life, right? Where they smoked their whole life, drinking a 12-pack of beer every day, eating fast food for 4 meals a day, and they don't get any exercise at all, okay? So this person has only saved up $80,000 for retirement with the thinking like, I'm not going to live that long anyway, okay? This person's not the best investor, so they just kind of throw it all in a savings account. And when I put 0.5% interest here, and you may be thinking, gosh, I've been using 5, 6, 8, even 10% interest on all these. Well, that's because we've done actual, like, putting things in a real retirement account, which invests in mutual funds and all these things that you can learn about in investment courses and finance courses. If you're just sticking money into a savings account, especially if it's at your local bank, you should actually look at what that interest rate is. There are plenty around here that literally give you like 0.1% interest per year, right? Where you're not even getting close to canceling out inflation. So this is actually, while this number may seem small, it's actually not that bad for, your standard brick and mortar banks savings accounts. Okay, so that's what we're going to use, this 0.5% interest. Let's make sure we're identifying all those variables correctly. So we've got $80,000 for their principal. Their interest rate is not 0.05, it's 0.005. So when we see that 0.5% interest and we move that decimal place over 2 places, that's 0.005. So be very mindful of that as you're transforming these percentage interest rates into decimal interest rates. We're pulling out this money once a month, so that'll be 12 times a year we'll be making these withdrawals, and we're just going to need it to last for 5 years. Again, with that same negative aspect of after the 5 years, the money's just gone. Okay, same idea. I'm just going to plug in all those numbers and use every single decimal place my calculator gives me to make sure I don't make even the tiniest little bit of a rounding error. I mean, there's still going to be some, but it will theoretically not matter with how many decimal places we need in our answer. And I get $1,350.35. So yes, this $80,000 was much less than the $1 million, but so was only living 5 years instead of 25. So I've literally heard this phrasing from people before of, I'm super unhealthy, I'm not going to live that long anyway, I need to save that much for retirement. Well, I think all of you, most of my students understand how little money that is to try to actually live off of, and then it's gone after the 5 years. So don't do what this person did and decide, I'm not going to live that long anyway. I don't need to save up that much money. When you do that, you're artificially making yourself run out of money much earlier than you would need to if you were more mindful of the possibility that you might actually live for longer than that. Okay, so that's enough for talking about these payout annuities. It's, as I said, very similar to the savings annuities in terms of I might be saving or I might be solving for what the payments are going to be, whether they're payments into the account or out of the account, or I may be figuring out what the total value of the account is. So there's two different ways of looking at those two things. So not only be careful with which kind of formula, right? Compound interest versus savings annuity versus payout annuity, which one of those three, based off of compound interest formula, is just one lump sum that we're just leaving there. Savings annuity is we're starting at zero and just adding in incrementally money into that account, but putting it in. And payout annuity, which is starting from some amount and gradually withdrawing from it many times. It's not just those three. It's also looking at it from the perspective of, well, am I solving for what the total needs to be, or am I solving for what my payments into or withdrawals out from need to be? So just be careful with that. And as soon as you have the right formula picked, hopefully we're going to do enough of these calculations that part will be, tedious but straightforward by the time it will matter, in terms of exams or something like that. But picking the wrong formula is going to be just a disaster. So just make sure and be very mindful of making sure you're picking the right formula, the right tool for the right job here.